Hi guys, it's Loami, the ALX student over here. I want to take this time to take a challenge to explain you about malloc and dynamic memory allocation. So since I'll be using my device, so I will use my links to my GitHub to give you the actual examples of how the code works. Now, to start, let's talk about the case. Let's build a case for dynamic memory allocation, which is what malloc does. Why do we need dynamic memory allocation? So if you are familiar with C, you actually know this thing, right? Let's look at here. What you see here is a typical function, a typical main function that tries to create a string. And you know, a string is an array of characters. So let's say you want just to store a string, and you can create a string and give it a size of 20 bytes with hope that it won't exceed that. If it's low, then the rest of the memory block will be not used. So the problem with here is that let's say you don't know anything about the size of the string you want to create. So when I use this kind of memory allocation, you can sometimes allocate too much of the memory or too low of the memory. But the advantage is definitely that the memory allocation and deallocation is done for you automatically if you just do it in a function. But let's say for instance you're getting a string from the user, right? You're getting a string from the terminal and the user from just the user. So how do you know how much of the memory to allocate to that string? Or it's not even limited to string but any other data type. So how do you know how much memory to allocate? The sure thing is that this kind of declaration does not allow variable size declaration, right? You can do that with arrays. But here is how malloc come to the rescue. You can see the syntax of malloc. It takes an assigned integer, which is a number which represents the number of bytes that you need to allocate to this particular data type. Okay, so now malloc, it stands for memory allocation. Now when you use malloc, that means you will be able to give it a particular variable, not just the size but maybe a variable. Now you can pass in a parameter. If it's an if it's a terminal argument, you can just pass it through here and the function can handle it well. Now, for people who know about C, the difference between C and other languages, and basically why we at ALX you call C a low-level programming language, is because with C you have to interact with the hardware yourself. You need to allocate memory via malloc and other memory allocators like calloc or realloc, which are essentially modified versions of malloc to do some particular other stuffs. And you need to also free that memory after you're done using it. So here's how we do the particular thing. So we just assign the function, we use malloc to declare memory, and then afterwards we use free to free that memory. You can see the syntax. Malloc gets an int for the size, the number of bytes to allocate, and free gets a pointer to the memory to be deallocated. Now you can see a particular example down here. It's trying to create a string that is as large as the number of arguments that it's getting. Now let's go to the GitHub and try to see some of the examples. So you can see this is a function. It's called create array. It's meant to create just an array of characters, right? So you can see like create an array of cars and initialize it with a particular character, right? So what you can see here is that this this function is getting a size for the number, for the size of the array and the character to initialize with. And you can see here that the function tries to allocate memory with malloc. Now it is a good practice because when malloc fails, as we see here, it returns null, right? So it's a good practice to check if malloc did not fail in the process. So you can see here, if it failed, if the string is null, str, the pointer points to null, then this whole function returns null. And otherwise, so you can see what it does. You can see that it navigates to every single string, and every every location into the block of memory allocated, and it navigates there, and it it initializes that one with the letter C. So at the end of the day, you would have so many C's filled up with the memory. So now, yeah, this was an example of how malloc works. And so definitely in the function, you don't see, the thing is, after return, you can't write anything in the return. So the main method that's used to call this create array method, that's the one that will free the memory allocated. Yes, so I hope this gives you a little bit about malloc and how the memory allocation works in C. So thank you so much.